Hello, welcome to Introduction to Java Programming. In this session, we will discuss the basics of multithreading. What is a process? What is thread? What is the thread life cycle, etc. Let's begin. So in multithreading, there will be multiple number of threads. So we need to understand what is a thread is about. And all these threads are running parallelly. Then we call this as a multithreading. Multithreading is a form of multitasking. And in computer systems, the multitasking is done using multiprocessing, which is already there, and multi-threading, which was introduced in Java. So what is multiprocessing or multi-threading? Let's understand. So firstly, we speak of multiprocessing. All our computers are capable of multiprocessing. That means the CPU can process multiple things at a time, right? So many services will be running on a system, right? You can actually go and see the task manager in your Windows and find out the services which are running. All these are running parallelly. That means CPU has the capability to execute things parallelly. That means it switches between each and every process. And we will feel that all these processes are executing in parallel and we will be getting high performance, right? Yeah, so multiprocessing is already there. And on top of it, we have multi-threading. And we can create threads on top of the process. So in order to understand these details, let's actually go to my slide here. Yeah, we have process-based multitasking and we have thread-based multitasking. In process, what is a process actually? A process is a program under execution or an application under execution. So you have written an application. That application can be divided into a number of logical parts, and each part is considered as a process, and these processes can run parallelly. A process is a program under execution or is a part of the program under execution. And these processes are heavy because each process is going to have its own address memory. And whenever the switching takes place between the processes, the processor has to do a lot of things actually. So it has to load the registers, it has to update the memory maps, it has to update the list, and each process is associated with some process control block. So all the details have to be updated every time a processor switches between one process to the other process. So that's why we say the communication between the process is so high. That's why we call the processes are heavyweight. The multiprocessing is there already, but switching is a little difficult, and the cost of communication, that means it takes much time. Even though it takes much time, we will not feel that difference because processors work in nanoseconds, right? But on top of this particular process, what we can actually do is we can create threads. A program under execution is a process, and take a particular process, and a process under execution is a thread. So thread is a part of a process which is getting executed. That means your process can be divided into n number of threads, and these threads can run parallel. So you have second level of parallelism. At the process level, first parallelism is there, and each process we can create a number of threads, and those threads can execute parallelly. So you have second level of parallelism. So you will have high throughput, high performance, higher response times, etc. And the thread is a lightweight process. Why it is lightweight process? Let's understand. Let's go back actually here. So threads share the same address space because threads will actually use the same process, and process has the address. So threads are going to share the same address space. it need not to update the memory maps, it need not to update the list or load the registers. That will be taken care at the process level only, right? So the cost of communication between the threads is low. That means easy switching between the threads is going to happen. And threads are created on top of the process, so at least one process is required for each thread. Okay, so now let's define thread independently. Threads are lightweight processes. Threads are lightweight processes because a background is a process for it, and the overhead in switching between the threads is so less because threads are not associated with all these memory updations, memory maps, etc. And threads can be easily be created. Threads can be easily be spanned, means easily be created. And for every Java program, we have seen so many Java programs, right? And JVM creates one thread that is called main thread. Okay, so for every Java program, a main thread is going to get created. So whenever you have the main, that is the starting point, right? So JVM invokes it. We know that when it invokes, it creates a main thread. That thread actually controls our program. Okay, that we will understand with the example later on. So now let's understand the advantages. Okay, so what are the advantages if we have threads concept or if we have multi-threaded application? So definitely it enhances the parallel processing and it increases the response times to the user. And to utilize the idle time of CPU, CPUs are so faster, they work in nanoseconds. Most of the time they will be idle. You can actually check the CPU usage of your system and it will be idle most of the time. So we can actually make use of the CPU. We can fully utilize the CPU by writing multi-thread applications. And we can prioritize our work also. So you have a number of threads created and you want one thread to execute first. Then you can actually prioritize that and you can do that because we can set priorities for each thread that we create. Okay, so I will give one example to understand the multi-thread applications. Almost all the applications that you are seeing now in the real world are multi-thread application. So for example, you want to book a ticket for a movie. And the ideally, let's assume, in order to book a ticket, it takes 3 minutes of time. So because you have to select the movie, you have to select the seats and you have to pay. And in fact, you can actually purchase some food and beverages during ticket booking itself. Let us assume the overall turnaround time is 3 minutes. Now my question is, if 1,000 people are trying at the same time to book tickets, so how much time it will take for 1,000 people? In order to book one ticket for one person, it takes 3 minutes. How many it will take for 1,000 people? Is it 3,000 minutes? So 3,000 minutes is so big time, and in fact it is not actually. Okay, for 1,000 people also, the ticket booking time is only 3 minutes because all 1,000 will be independent threads and they will execute parallelly, right? For 1,000 people are trying at the same time, they will finish their ticket booking within 3 minutes only. That's because of the multi-threading. And almost all your ticketing applications, whether it is bus ticket or train ticket or airline ticket, it's a multi-thread application. All your e-commerce applications are multi-thread applications. At the same time, how many people will be booking a mobile if it is newly launched in Amazon or Flipkart? Right? All these are multi-thread applications only. Almost all multi-thread applications. Okay, so to give you more clarity, so this is the diagram. So whole is actually my application or my program. It is divided into 3 processes. So process 1, process 2, and process 3, and these processes will execute parallelly. And in a process, we can actually have threads created, and these threads also will execute parallelly. A thread is a lightweight sub-process, a smallest unit of processing. You can actually can't divide this thread. This is the smallest unit of processing, and each thread will have a separate path of execution, just like processes. That means each process will execute parallelly in the same fashion. In a process, these threads will execute parallelly. Okay, so that's about what is thread and what is process. A process is a program under execution, and a thread is a process under execution. Processes are heavyweight because they are associated with several other resources, and threads are lightweight, so that the switching between threads is so fast, so that you will get much user response times. So let's understand thread life cycle. Okay, so there are 5 states actually. So thread once created, and it will be there in 5 states. It may be there in 5 states. At least 4 states are 4 states are there. Actually, mandatorily will be there. But sometimes it can be in 5 states also. So what is the life cycle? Life cycle is actually the duration between its birth and death. When a thread is created, we can say it's born, and when thread purpose is done, then we can say it's actually expired. So the time duration in which the thread from birth to the death, what are all the states it resides, that is called thread life cycle. So here onward, we need to understand the life cycles: thread life cycle, then servlet life cycle, and JSP life cycle later on, other advanced Java concepts. So thread will be there in 5 states during its lifetime. So first is new. Whenever thread is created, it is in the new state. Okay, so let me explain this. So there are 5 states. Whenever a thread is created, something like this: thread T1 equal to a new thread. So thread will be created, and it is going to be a new state. And the next, upon calling a method called start. So for example, T1 is the thread that is created. When I say start, T1 dot start, now thread actually is going to be in runnable state. The new state means thread is created. So we have different approaches to create a thread. Of course, I can create thread T1 equal to new thread, because thread is straightaway class available in lang package. I can create like this. And when I say T1 dot start, it is actually in a runnable state. That means runnable, or we can also say ready state. The thread is ready for execution. Then we have running state. What do you mean by running state? So now thread actually run something called critical section. We have something called critical section in the multi-threaded concept or multi-processing concept. So this is the section which is being executed by all the threads. This section is nothing but a block of code. Okay, and all threads compete to execute this particular critical section, and this section we will actually write as run method in Java. So this is the critical section. The run method is actually the critical section in Java. And if a thread was given chance to execute this run method, then it is called running state. After successful running of the run method, the thread will get terminated. That means it will end. So that means it exits from run method. Whenever it exits from the run method, and we can actually say it's terminated. But during the run method, the thread may be waiting for certain resources, some IO resources. It may be blocked for IO resources. It is waiting for the IO, so some data to be given. So it has to wait. So user has to give the date, or it want to write somewhere, right? So it can actually wait for that. So that then it will go to the blocked state. When the thread is executing the run method, it can be interrupted. It can be suspended. It was asked to sleep. Okay, so there are a number of scenarios where thread can actually go to this blocked state. Okay, so thread actually during its lifetime can be there in 5 states. First state is born state. Second state is ready state. It is ready to execute the run method. If it is picked by thread scheduler, you need to understand something called thread scheduler also. So because this run method is actually under the control of thread scheduler, we just write the run method, but we don't have any control on that. So thread scheduler is also part of JVM, just like the garbage collector, that will actually controls this run method. If any thread wants to execute the run method, it should be picked by thread scheduler. Then only the thread will run the critical section. Okay, that is something new that we need to understand in thread multi-threading concept. Right, so when a thread is created, it's in a new state. When a start method is in thread class, it is called on the thread. Now it is ready to execute the critical section. That is nothing but the run method. And if thread scheduler picks it, then it executes the run method. And while executing, it may be asked to sleep, it may be suspended, or it may be waiting for some lock, and it was called with a wait method. Then it actually goes to a blocked state. So whenever resources are available, whenever the wait is over, whenever the lock is available, it can come back again to the ready state. And later when picked, it will go to the run state, running method. And when successfully executed, then it actually ends. So these are briefly the 5 states in which thread resides in. The same thing has been explained over here. When you create a thread, then it is in the new state. And whenever the start method is called, it will be actually a runnable state. And now it is ready for executing the run method. And if the thread is running the run method, that means it is selected by the thread scheduler, then it is in the running method. And while running, it may be thread is still alive, but what happens? It is actually waiting for some resource. Maybe IO resources or some methods are called on it, right? So then it is in blocked state. Okay, whenever those things are available for thread, it can actually come back to a ready state and then running, and run is successfully exited, then it will actually into dead state. That is a terminated state. Okay, so from this, the point here is every thread is created to execute the run method. The objective of a thread is to execute the run method. That's the purpose, because when it successfully executes the run method, it is done. Right, now you can actually see here very much clearly. So when the thread is created, it is actually in the new state. Okay, and then it is going to be in runnable state, right? And while running, what can happen is thread was asked to sleep. Thread can block on IO. Thread was called with wait method. This is the wait method, last one. Thread may be waiting for certain lock in a synchronized environment, and thread may be suspended. So these are all the scenarios where a thread actually moves to blocked state, or we can say non-runnable state. Right? So when it is blocked, other thread will come. This other thread exits run method successfully, then it is actually terminated state. Right? And the blocked thread can actually resume or can actually wake up when the sleep is done, and it can complete the IO, and it can actually get the lock. Then it goes again the runnable state and comes back to the running method, and it successfully exits the run method, then it is terminated. Okay, so this is about the thread life cycle, and later we will understand what are different ways to create threads. So that's the programming part, and this is just the basic part actually. So what is thread life cycle? What are the states and what is a thread? What is a process and what are the uses of multi-threading? And to sum up, multi-threading is a process in which multiple threads will be executing parallelly. And the cost of switching between the threads is very low because it will share the same address space of the process. Whereas a process switching is very heavy. That's why processes are called heavyweight resources and threads are called lightweight resources. Hope you have understood the basics of multi-threading. And in the next session, we will see how we can create threads in Java. Thank you.